Okay, this is question 7 from January 2022. Big question involving connected particles and angles on the plane. So, really useful one for you to have a look at. Let's get started straight away in terms of the length of the video. So the one thing that I have done is I've already drawn out my diagram and I've already put on the tan alpha equals 3/4, sine alpha then working out to be what that is, and cos alpha working out to be what that is. At this stage, I'd normally put my mu there as well, and the other thing I'd do is to say which way this thing's going to be going to help me with my equations of motion. So let's do what we normally do, which is to put on all our forces, then we can resolve them. I'll start with the force acting at Q. So we've got the weight acting down, and obviously that means we've got a reaction force acting up there. We've got a tension in the string and another tension in the string. We've got a weight acting down at 4 mg there. We'll have a reaction force over here. Let's just tidy that up in terms of neatness. At P, I haven't said that this is P, so let's put that in now. This is point P here. So this is going to be RP there if the other one's RQ. And then let's just talk about the surfaces. The inclined one is a rough surface, which means there's friction. Because the particle is moving in this direction, it means friction is going to be moving in the opposite direction. And just because of my diagram, I'm actually going to put my friction force there rather than where the two tensions are, rather than where T is there. Once I've got those, then that's all my forces. Yeah, there is no frictional force acting in that direction, which means to a certain extent I'm not going to be using R equals mg over there either. Let's resolve our forces as we would normally do. Not a lot of forces involved in this, so this is just our classic situation here, that's alpha. So that's 4 mg cos alpha, and this is 4 mg sine alpha, and now I've got all my forces on my diagram and I've resolved them all. So at this stage you choose F equals ma, you choose F equals mu r and resolving, but in the question they've given you a start, they've said for part A, write down the equation of motion for Q, which means consider Q first of all. Okay, so if we're considering Q, I'm still going to tell you what I'm doing, even though they've asked me in the question. The equation of motion is the F equals ma part. That's what they mean by equation of motion. So in this case, we've just got T equals ma. Mass is equal to m, so we've got T equals ma. A little bit different really from what we've had before, but not particularly complicated. What I could add in here, if I just want to keep everything as consistent as possible, is to say resolving horizontally. I'm a big believer in just telling everybody exactly what I'm doing. These questions can get quite lengthy, and I like to stick to a pattern. Following on from that pattern then, I'm going to consider Q now. That's the answer, by the way, to part A. Consider P, sorry. And when I'm considering P, I'm going to resolve perpendicular to the plane and then parallel to the plane. So resolve perpendicular to the plane. F equals ma. I'm just going to get RP equals 4 mg cos alpha. Okay, there's no other forces acting here. It's a relatively straightforward one in terms of the forces there. So just a quick check of it, but yeah, no, that's absolutely fine. Then I'm going to do F equals mu r. That's always the next thing that I do with these questions. I'll finish with F equals ma. F equals mr, so F is going to be mu is a quarter, 4 mg cos alpha. And at this stage, I'm just going to tidy this one up. So that's mg cos alpha, and cos alpha was 4/5. So F just works out to be 4 mg over 5. Okay, another good reason for doing these questions, we see things like equation of motion as a question, and you see how quickly I get into tidying things up in terms of keeping them in terms of G's, etc. Last part of this one, resolve parallel to the plane. Really doesn't take me more than an extra like 15, 20 seconds to do these things, and yet it makes such a difference to somebody who's marking your work. They can see exactly where I'm working now. Handwriting not great there. F equals MA. Let's go back and see what we've got going on here. A quick check to make sure you're happy with the directions of your forces and everything. Yeah, friction's opposing the motions. At this stage, you might want to do double check there. So I've got the F and the T are acting together. The 4mg sign is acting in the opposite direction. Because we know it's going downwards there, I know the 4mg sign is winning. So 4mg sine alpha minus T minus F is equal to 4MA in this case. Chuck in everything that you know. So 4mg, we know 3/5. And we know that F was from before 4mg over 5 is equal to 4MA. And again, just tidy that up a little bit. You've got 12mg over 5 minus 4mg over 5 there. So that's 8mg over 5 minus T is equal to 4MA. And this is where doing lots of questions helps you. We know that this one alongside the second one, that's what I was hoping to get so that I could then add these two equations together, because that's what I normally do when I get to this stage. So if I say that there, 1 plus 2, I'm doing that so that the t's cancel. So I'm going to get 8mg over 5 equals 5MA. Get rid of the m's. A is going to be 8g over 25. Everything nice and neat, everything in terms of exact values here. And I didn't really properly check the question, but the question said tension, not acceleration. So tension is equal to mass times acceleration from number 2 there. So tension is equal to 8mg over 25. So you really want exact values when you can in terms of these things. Let's just go back and check the question. Yeah, it didn't say in terms of exact values. So you could have had it as a decimal, but it's nice and neat and simple to do that way so far. Okay, on to part C. What does part C say? Part C says find the magnitude of the force exerted on the pulley by the string. Okay, so yeah, this is one of those where I've told you before. I've actually just prepared the diagram out here. Where is it? Let's just bring this up. This is a situation we've got then where we've got this tension, the two tensions acting there. Now, they could have asked me an easier question. If it had been just a 1-mark question, they'd have asked me what direction it's going in, and then it's the line I've drawn in, that red line there. It's the bisector of this angle here. Let's just do that in a different colour. It's the bisector of that angle there, okay? So what we can do is we can work out that angle there just using a quick bit of IGCSE angle work. We've got a Z angle there, we've got an alternate angle in there, so that means that this angle is alpha, which means that this angle is 180 minus alpha. So when I'm now saying about theta here, whoops, theta is going to equal 180 minus alpha, all divided by 2 there. And then I've told you a shortcut to working out the tensions is going to be force. The force on the pulley is 2t cos theta. So in this case, it's 2t cos 180 minus alpha over 2. And I say this is all about shortcuts in terms of this one. We know up here all the information about alpha, so I can actually work out what alpha is. Let's just show them what I'm doing. Tan alpha equals 3/4. So alpha is equal to, let me just do that on my calculator. Yeah, that works out to be equal to 36.869, let's say 870. So alpha is equal to that. So the force works out to be 2t cos 180 minus 36.870 all over 2. We know that T is equal to 8 mg over 25. So actually we've got 16 mg over 25. Times by cos of that bit there. Let's put that into the calculator. And if we put it all into the calculator, the exact answer given by Solution Bank is that, but it's also the same as 0.2, I think it is, mg, and we would just be happy to leave it like that in this case, saving ourselves a lot of time rather than doing Pythagoras and all sorts of other bits and pieces for that. And then for part D, what does part D say? State where in your working use the information that the string is light. So again, I'm really delighted with this question because it's given us all these things that you should have sorted out now. If the string is light, then tension is the same. Now you can either say either side of the pulley, or you can say throughout the string. But can you see the importance of going away and learning those facts that I gave you just so that we get that extra mark? Okay, big question that, but definitely worth you all watching.